an electrical engineer, measuring soil moisture looks like a simple problem. It's so simple that you could just put a couple of nails in the ground, wire up a readout, and estimate soil moisture. When we started developing our soil moisture sensors, our goal was to dramatically improve accuracy in the field. Plus or minus 1 dielectric may be the best accuracy any single dielectric sensor can achieve, but we had a bigger goal: to help researchers reduce the uncertainty in spatial data so they could better characterize what's really going on. In order to do that, we had to make a low-cost sensor so researchers could cover the landscape with them. So how do you build a low-cost research-grade sensor? That was our challenge. We decided not to outsource production. We kept it all in-house so that we could control the important things like quality and consistency. We maintain ISO 9001 certification. We do extensive testing of 100% of our sensors and calibration of all our digital sensors in-house. The sensors are designed to reduce noise for a clean signal that's relatively unaffected by soil texture. It's not perfect. Soils with high salinity and high clay content are still a challenge, but in most soils, it's very, very good. Once a month, we pull 3 random sensors of each type from production and test them in primary dielectric standards. Although these solutions do damage the exterior of the sensor, it gives us long-term data about the consistency and variability in the sensors. We keep working to improve our overmolding process so that the sensors are protected from the elements. Our goal is to have sensors that can last for more than 10 years. We put different designs in various accelerated life tests to see how a sensor might perform over time. Of course, we've also been testing our improved designs at a wide variety of sites. We've learned so much from sensors that have been producing data for 2 years at sites on the Wasatch Plateau, an area that is particularly harsh to instrumentation. We have more sensors right on our own backyard in the Cook Experimental Farm at Washington State University. That's because what's most important to researchers who use these sensors is something you can't see in the production process. We know that it's not just about good electronics, but about verifiable, publishable data. We have scientists here at Decagon in a number of fields: soils, plant physiology, and hydrology, with well over 100 years of research and instrumentation experience. People call us not just when they have sensor problems, but when they are trying to interpret their data. We can look at data and see if the wrong calibration is being used, help people remove sources of error, or figure out what they need to do next to interpret the data. People have jokingly said to me, "Thanks for the help. I really need to put you as an author on this paper." That's what we count as success here at Decagon. Not just that the instrument we sold you works well, but the data you get from it helps further the science.